Hello friends, welcome to C# Intermediate to Advanced tutorial. In this sub-series, we are talking about C# ICloneable interface. In the previous video, we learned about the basics of value type and reference type and how stack and heap memory allocation unit refers to reference type and how value type ties only to the stack frame. In this video, we will learn about ICloneable interface. So ICloneable interface asks you to provide implementation for clone method. So for your custom class, you have to implement ICloneable interface. Then you have to provide or you have to override the clone method. So the clone method tells how to create copy of an existing class instance. Say for example, you have a class called employee, and if you want to take a clone of employee, then you can make use of the clone method. So the clone method will create a copy of employee and it returns the copy to the caller. Clone method is to provide copy of the existing object. So that's what we will implement inside this clone method. We can implement clone method to create a shallow or a deep copy. Now we will understand what is a shallow and a deep copy, because we have to know what is a shallow and a deep copy as it is ICloneable interface. When we are learning it in the next coming videos, we may be referring this shallow and deep copy multiple times. First, let us talk about shallow copy. Let's say we have a point object, point class, and this point class has two members, x and y. Let's say both are integer, and then a line class. So the line class contains two point instance. Let's say we have a heap, and in this heap, let's assume that we have two line objects. Let's denote that as L1 and L2. And we will also consider the L1 object. Let's say it's a line instance of type line, and this is also a line object. Since it's a line object or a line class, we will create this using the new keyword. Since we will create this using the new keyword, the actual object stays on the heap. And it will have 2 point, right, as already told. Let's say point instance P1 and P2. Similarly, let us consider we have one more line object. This line object also contains 2 points. Let's say P1 and P2. So the line is denoted by point P1 and P2. Now let's say that we first constructed the line 1 object, and while we construct the line 1, we also constructed the point 1 and point 2 also. So there are two objects, right? Line object contains an instance of a point object. So let's say this is A and B, AB, CD. So when we construct object, we will have a p1. P1 will be the reference. So here the content will show address of some other location, and let's say this is one location AB for a point, and another one is location CD. So this will have two slots, X and Y. In X, let us say we have value 10, Y also 10, and for Y, let's say 5. So this AB is pointing here, and if you see the content here, point P1 is a reference, and the reference is storing some address location within the heap. So here the location itself a heap location, because line 1 is constructed on the heap, and in that heap location we have a reference for point P1, and that contains the address location of some other location in the heap AB, and inside that AB we have X and Y. X and Y is value type, and here we doesn't store any address, instead we directly store the value. So X is 10 and Y is 10 for point P1. Similarly for point P2, X is 5 and Y is 5. Now let us say we are performing a shallow copy here from line 1 to line 2. Line 1 to line 2, in the sense the copy will go like this: L2 equal to L1. Likewise, let's say we are performing the copy from L1 to L2. What happens? The content from P1 to P1 copy will occur. When copy occurs, the content AB will get transferred here. It's a bit pattern copy, right? Shallow copy means a bit pattern copy. So here the same bit get transferred, and here CD will get transferred. Bit pattern, that is representing this location AB, that will get transferred here as part of copy, and P2 same bit pattern CD get copied here. So when the content whatever is here in P1, if it get copied to the other P1, L2's P1, then what happens? After the copy, this will also point to the same location. Similarly, the CD will point here, same location. So this is what called a shallow copy. So in shallow copy, if you see, we have two different heap location for line 1 and line 2, but its internal members, point P1 and P2, these are all reference type, right? P1 is holding the reference and actual object is in the heap AB. Once you make a shallow copy, you are copying the location association to the other P1 on L2. That means after that copy, after the shallow copy, both will point to the same instance. Now if a user access L1 or L2, and let's say they change point P1 from 10 to 20, if you see, if they change it through line 2 object, it is reflects on line 1 also. So then the copy is not a right one, right? So that's the a problem with the shallow copy. Alright, now let us talk about deep copy. Once again, we will consider, let's say this is the heap. So inside the heap, let's say we have same object L1, which contains point P1 and point P2. Let's also consider L2, P1 and P2. So as usual, let's say user created line object L1, and let's say the location is AB. Here also, let's say CD. So this is the location in the heap AB, and let's say it contains X as 10 and Y as 10. And there is one more object, C, D, SA, X is 5 and Y is 5. Now this is pointing here and point 2 is pointing here. So in shallow copy you saw that the content is copied, the address is copied directly. AB is copied here, CD is copied here. So that's the default behavior on okay, so that we will discuss later. So this is the shallow copy. Shallow copy means you copy the bit pattern here from P1 to the other object P1, or we can say from source object member to destination object member, you will just copy the bit pattern. So once you copy bit pattern, what happens? Both will end up pointing to the same heap location. In deep copy, what happens when you ask for a copy? That means if you want to copy L1 to L2 in deep copy mode, what happens? Here we will create a new instance of a point. For P2 also we will create new instance of point. That means we will use new keyword and we will create a new instance. After that we will copy the content here. Let's say when you create new instance, P1 may be storing a different address. Let's say M N PQ. And after that we will copy the value from AB to M1. So the copy actually occurs like this here. Here we copy the content, we create new instance. After that we copy the content 10, 10, 5 and 5. M1 is pointing here and PQ is pointing this heap location. If you see, there are totally 4 heap locations. So these 2 also a heap location, but since line 1 is referring 2 point instance and the L2 is referring 2 point instance, there are 4 points in total and all 4 are at a different location. Here in this case, if you see, first we created line 1. Line 1 object is in the heap. That's one instance. Then line 1 is having 2 point instance and those 2 points instance are here. So there are totally 2 point location and 1 line location. Next, when you construct L2 by means of copy, and if it is a shallow copy, then there will be no new instance. The content or address content will get copied here. If it is AB, that AB is get copied to P1. So thereby ending up pointing to the same location. Here if you see, since in deep copy we actually create a new point, then we copy the content of the L1's point to L2's point. In this case, what happens if user changes a point 1's content from 10 to 20, it is not reflected on L2. Why? Because it is pointing at a different heap location. So if you change here, that reflects on L1 only. Similarly in L2, if I change a point to 5 to 15, then it reflects only on L2, not on L1. So this is what called deep copy. So why we are talking about shallow copy and deep copy? Why? Because here we are learning about ICloneable interface. Cloneable means we have to create a copy of the instance and give it to the user. So for example, if we create a class called student and if it has some 20 members, then when user asks for a clone, then we have to copy the content of these members to the copied instance and give it back to the user. So that time the shallow and deep copy comes into picture. Alright, so now you know what is shallow copy and deep copy. When we implement clone, it is up to us to perform copy of the entire member or only selected members. So here we are implementing the ICloneable interface and we are implementing the clone. So when we are implementing the clone method, it's up to us to decide whether we want to copy all the member or some specific member. How do we call student 1 is a clone of student 2? So it depends on what are all the member we will pick and copy during this cloneable or during the clone method implementation. So the standard is copying all the member, but some people will implement it differently by picking a selective field. So for example, if there are 20 members in a class, they may pick only 15 and perform copy, and they still say that the copied one is a clone of the previous one. But the remaining 5 member may be different in both, but it's up to the developer how they call one instance is copy of the other instance. But the general advice is to copy all the member to the destination. When we implement clone method, we can call MemberwiseClone to copy the members. So clone method we will be implementing, say for example, if we have a student class and if that implements ICloneable, and inside he will provide implementation for clone method. Inside the clone method you can make a call to MemberwiseClone, this dot MemberwiseClone, and MemberwiseClone will give you a copy, and by default it will perform shallow copy and you can return that. Or so that's what a MemberwiseClone will do. First let's understand what this MemberwiseClone do. The MemberwiseClone will perform the content copy, I mean the whatever is the content here, address content. So if it is 11101, that represents a specific address, that bit pattern will get copied here, so that the same binary number will be there here that represents the same address. So that's what a MemberwiseClone will do. MemberwiseClone will also create a heap, create a object on the heap. Okay, to explain it properly, let's say line object. Inside the line object we are implementing the clone method, and when you make a call to MemberwiseClone, the MemberwiseClone will create a new instance L2. You are calling MemberwiseClone on L1, so it creates a new instance on the heap L2. Copy the content. When it is copying the content, it performs shallow copy and returns the object. So you will be getting L2. If you see, you get new instance L2 because you are calling, new instance L2 means the line instance, but you won't get a new instance for the internal members. So they refer the same heap location which was already created. This is source, right? This is source and this one is the destination. So the destination will be created on the heap when you make a call to MemberwiseClone on line object, but internal members, if they are a reference type, and since bit patterns are copied, they points to the already existing location. And the MemberwiseClone will, after the clone, it will return the new instance created to the caller. So that's a MemberwiseClone. But when it is called on line object, it creates a new line instance. Internal member only it performs this is shallow copy, and the shallow copy problem exists when you directly call MemberwiseClone. But if it is a value type, let's say instead of point, if it is X and Y directly here, or if you implement this MemberwiseClone on the point object itself, the point object internal is actually a value type, integer and integer, right? So when a bitwise copy happens, they both have a different, let's say this is 0.1, this is a 0.2, and if you make a copy, it doesn't point to any other address. Why? Because the content itself here value 1, value 2, and here it will get copied value 1 and value 2, and when you change value 2 to value 6, it reflects only on here. So that's why MemberwiseClone works well for value type. When the internal members are value type, copying the content doesn't harm you. But here, since it's a heap location, both pointing to the same location will give some trouble. MemberwiseClone creates new instance. That's what we are talking about. It creates new instance like line 2 and copies member content AB. I mean, here in this example, point P1, P2, the content is some address location AB. Copies member content bit by bit. So since it is copying this bit by bit, let us say AB we told, right? Instead of that, if you see bit pattern means it will be like this 0 1 some address location, right? This bit content bit by bit, it will get copied to the destination. So when it is copied, so this bit pattern is representing some other address location. That's where the point 1 instance is created, right? So that's how when bit by bit contents are copied, both will point to the same location. Means if a member is a ref type, MemberwiseClone performs shallow copy. This is what we are talking about. So if it is a reference type, if it is value type, no issues. Why? Because the content itself a value, it is not pointing to some other location. So this content itself a value, later when user changes this value, it reflects. Here also in reference type, if user changes this address content to point to some other location, there is no issue, right? Here we are just talking about bit by bit pattern copy, and they're both pointing to the same memory location. All the reference type data member should also have clone method implementation. All the reference type data member, here if you see L1, for L1 we will implement the clone method, and for point instance also we can implement the clone method by extending it from the ICloneable interface. So for all reference type data member, all the reference type data member should also have clone method implementation, so that containing object can call the clone method. Containing object in the sense here L1, and if it wants to perform a deep copy, it can make a call to point 1 p1 dot clone, p2 dot clone. Likewise, it can call a clone method. After that, it can perform a content copy. If ICloneable implementation is not available for the contained member, we need to create a new instance and perform data copy. So if the point 1, let's assume it already has the ICloneable implementation, then you can simply call p1.clone, then you can give it to p2, and similarly for other instance you can do p1 p2.clone, and you can give it to the destination p2. Destination p2 means here we are talking about L2, here it's for L1. From L1 you will make a call to clone and you will give it to p1, then using a p1 dot x you will change the value. So likewise you can create a deep copy. So clone means it will create a new instance, we know that, right? So line 1 here, when you make a call to MemberwiseClone, it will give a new instance. Similarly here, if you go to clone method, inside the clone method we may be having MemberwiseClone, and that will give a new instance. So at this stage it may be slightly confusing, and in the next few videos when we implement ICloneable interface for our example, we will get a clear picture of what is shallow copy and what is deep copy, and how to use the MemberwiseClone method properly. All the stuff you will learn in the next coming videos. But for now, you can understand the difference between what is shallow copy and what is deep copy. And in shallow copy, address content is copied, thereby source and destination both points to the same reference type instances. Here we create a new instance and we copy content only. So there is no demo here. Thank you for watching. Bye.